This is, let's pretend this never happened. Common T-SQL coding mistakes and how to fix them. Who am I? My name is Amy Harold. I am from Dallas, Texas. I am currently a senior database administrator at One Technologies out in Dallas. Who's on Twitter? Oh, everybody should be on Twitter. It's amazing.
But I don't need 140 characters to stay free.
But this is true, but it's a nice place, and there's lots of good people out there. So, you know, if you do a lot of SQL, there's SQL help and things like that. So I like it. I'm on there. So you should be there because I'm on there. And I'm Texas Amy on Twitter. I blog over at SQLkitten.com. And I am also the Director of Programs for the North Texas SQL Server User Group, as well as, in a previous role, labeled the meanest DBA in the world. So that Post-it note was left on my desk after our SQL developer refactored some code and got it down from so many minutes down to 30 seconds. I said, can we do better? And that wound up at my desk. And then later on, he came back and highlighted the word meanest after he forgot his password to our PDW or APS appliance. And I reset it to don't forget your password. But this is Texas, so I had to embellish that a little bit. So it was don't forget your password. Exactly. He didn't find it funny. I found it hilarious. All right. So the agenda for this session. First, we'll cover some common T-SQL coding mistakes, talk about what a few of those are, things that I found that I think are common mistakes that I normally look for when I'm reviewing code. As a DBA, you might be tasked with doing code reviews, or you might just be identifying some long-running code in your environment, and things that I've looked for in those instances. We'll talk about reviewing statistics, gathering those and reviewing that data, as well as gathering execution plans for your code and reviewing those. Followed by, we'll talk about Query Store and how that can help you with your performance. So, caveat for this session, as with everything in SQL Server, it depends. You might have some code changes that you make that kind of fly in the face of what I talk about here today. Heck, I might do some that fly in the face of what I'm talking about here today. It really depends. Depends on the situation, depends on your server, depends on the load. There are lots of variables that go into performant code, not just the code itself, although the code itself is typically the first place I like to go look for things, because 9 times out of 10, that code could use some improving. Although I know nobody in this room has ever written any bad code at all, right? Never, ever. All right. So, some common things that I look for in poor performing code. First off, cursors. Yikes. These things can be problematic, to say the least. In one position I was in, I refactored code that had cursors in cursors and was part of not only part of an overnight job, but these same stored procedures were also called by our website during the day and were the source of timeout issues. And so both things, the timeout issues, the overnight job running well over 12 hours or however long it was running, both of those things were really bad. I refactored that code with some correlated subqueries. I got in there, I dug into the logic of it, and found I was able to turn those cursors into set-based operations and eliminated them altogether. The developer who wrote it was very shocked by this, that I was able to accomplish this, and literally said to me, how did you do that? And I showed him, and I was winning. It was great. Stack CTEs and views. While you might be able to stack CTEs and views for that matter, unraveling those things when they are problematic can be its own problem. If you've ever, dug into a view and found another view, and then another, and then another, you feel like you're going down a very large rabbit hole with no end. Until you finally get to the one view where there are no views, just tables, and you breathe a small sigh of relief, and then you start to work your way back up out of the rabbit hole. So, if you're putting things together in CTs and views, some options there, temporary tables, are a great option, an alternative to, stacking those things together. You can load things in temporary tables in your stored procedure and then join on those. In many cases, that's a better, more performant way to do things. User-defined functions. Typically scalar functions, in most cases, they are okay, but in some cases they're not okay. And if you can change those to something else, maybe a table function, or remove the function altogether, that may be something to consider. I've done code reviews before. I've looked at stored procedures and that had a function call, took out the function call, and my performance problem went away completely. And that's when I knew I needed to go review what was going on with that function and try and eliminate that. Subqueries. Subqueries are great in some cases. As I mentioned, I wrote correlated subqueries to resolve the cursor issue that I had. But those can also prove to have their own performance issues as well. If you are having a performance issue related to a subquery, dumping that data to a temporary table, or seeing how looking at your statistics to see if there are any changes that could be made to improve the performance of that particular query within the entire stored procedure you're writing. Also, table variables versus temp tables. If you have a stored procedure or some code with a table variable and you're having performance issues, try converting that to a temp table. It might be that there's so much data being pulled back into your table variable that it's problematic, and the optimizer can't, can't handle that much data within a table variable as well, and maybe a temp table would be a better option. All right, so reviewing statistics. Does everybody here turn on statistics when they're looking at queries? Not everybody? Yes? Okay. I always do this, especially if I'm having a hard time getting an execution plan returned. If it's really bad and I can't even get a plan, I'm hoping at least I can get some stats. Look at stats.io, time. Profile is not one I use a whole lot, but it's out there and well documented by Microsoft. Statistics parser. There's a website out there, and we'll take a glance at that today, by Richie Rump. And I checked this out. This is really neat. So if you're looking to make some code changes, and also you have to make the case to the business before making those code changes, the output he gives you is in a graphical format and could be very useful for making that case. So, say you have to compose an email regarding the code change you want to make. You can, plug in your stats here, see what comes out in way of graphics, and you can use those to try and graphically demonstrate for, non-SQL Server professionals, what you're looking at, what you're dealing with, why we need to make this change. Within statistics, scan count. How many times was the table scanned in your query? This is really important. If you're scanning a table multiple times, that's not good. We don't want to be scanning your table over and over and over again, especially if it's a very large table. Logical reads on the table, as well as the physical reads, reading data from physical disk, read aheads, and also large data, logical reads, physical, and read aheads. Statistics time. You have CPU and elapsed time. So when collecting this information along with an execution plan, you can compare the two. Going through my demos for this session, I found a few cases where the stats, my plan looked a little ugly, but my stats told me that my uglier plan, this one particular query, was actually faster than the plan that wasn't as ugly. So, it's one more piece of information for us to analyze and, see what performs best for us. Execution plans. When you gather your execution plans, it's always good to both look at the graphical and the XML. You can search the XML really easily for warnings, errors, things of that nature. Also, another website to look at, How's My Plan by Daniel Janik. I know this guy, really great guy. He's put together a really neat site here. You can save off your plan, upload it. He doesn't keep these. He doesn't save it. He says it right there on the site. He does not keep these. And it analyzes the XML of the plan quickly and will return you an analysis of it, with any errors or anything you should look at highlighted in red. So if you don't know exactly where to start looking at your plan, this is, one way, quick and easy way to get some quick information. Query store performance. So Query Store came about in SQL Server 2016. And here's a quick link here. This is to some Microsoft documentation, and we'll look at some stuff later regarding Query Store and how that can help us with our performance in our queries. All right, I think my slide deck's out of order here because we're not going to Query Store just yet, but we are going to do some demos. All right. Bless you. Let's see. There we go. Duplicate my screen so y'all can see what I'm seeing. Do I need to make this bigger? Yes? Yes? Okay. I shall make it bigger. And we'll shrink that down for the moment. This good or even bigger than this? Good? Yes? Okay. We'll leave it there. All right, so we're going to start with something simple. So I have some different variations of getting the exact same thing returned, but we're going about it different ways. So first of all, okay, so I'm working with my purchase orders table here. I'm using the Worldwide Importers database and looking at purchase orders, but I'm pulling back a date with purchase orders, and I'm doing this several different ways. And we're going to look at the plans and stats for all this. So first we have just a get date along with purchase orders, followed by an outer apply of a view. What does this view do? Let's go see. Where are my views? Wrong database. All right. There we go. So what does this view do? Get date. And then finally, we're declaring a date variable and passing get date to that. So let's see what happens here. Let me make sure I have my plans turned on. All right, so we can see here, we got the same data set each time, except the first one doesn't have dates to it. What happened? Well, okay, so our first query with no dates ran in 257 milliseconds. We don't have that many logical reads. This is, it's okay query. Even when we add date, actually our next one, we added the date and it ran slower. We probably had a cache version, or it was pulling from cache. The next one ran even faster than that. And the final one, with the date variable, ran the fastest. But what about our plans? I'm going to use SQL Sentry Plan Explorer here and blow this up. All right, so first query just scans our clustered index. Next query, since we have that get date, we do have a compute scalar function being called there along with our cluster index scan. But the next one, where we joined on our view, this one also includes a constant scan within the plan because we joined to that view and we have a nested loop join as well. And the last one with our date variable, that one was the most efficient. I believe the first one and the last one are exactly the same. We're just scanning the clustered index and that's it. So with this particular situation, we have 3 queries that do the exact same thing, but the plans are way different. My emphasis here is, when you're doing code reviews, when you're doing coding of, T-SQL code of any kind, and you're not getting great performance, it could be just something as simple as, changing to a variable or, changing things up, not necessarily a view, maybe using a CTE. It really varies. So let's move on from there. Let's look at some queries where we're doing some function calls. So similar here, I have a query where I'm calling a number of user-defined functions along with some data. And then I have, instead of the function calls, I'm using a CTE. In this query, I believe we're running out of AdventureWorks. Let's run this, make sure my plan's going to happen. There we go. All right. So on the first one here with our functions, once again, the same result set. Let's see what our stats say. So we're only scanning each of the tables one time in this case, but our elapsed time, that's kind of high, over 2,400 milliseconds. Come down to our next query, much better on the time. We have a lot more going on here, but we're not seeing anything huge in our scans or anything like that. So this one, about the same, a little bit shorter. Let's look at these in more detail. So obviously the first one is the function calls. The second one, I condensed the functions into a single CTE to see what would happen there. And then the third one, I broke each function out into its own CTE. I have found cases before where I saw some code and with stacked CTEs, and it did not perform well. In this case, this was a better performing option than the others that we have. So like I said, within SQL Server, it does really depend on the situation. Let's look at these with SQL Century Plan Explorer. So our first one here with our function calls, here's the plan that came out of that. We're doing a lot of work on our clustered index scan. So there's that we're scanning cluster index on, it looks like on the same table, maybe not the same table, twice. But our next query, the plan itself got a little bit bigger, but our performance, we saw that our elapsed time was far less than our first query. So, and most of the work here appears to be, we have a hash match inner join, bringing things together. But our last one, which was the fastest, has the biggest plan. So suffice to say, just because you have a plan that's huge doesn't necessarily mean that the query is poor performing. There might be some things here to look at, but it may be the best option. All right, so let's go on to something bigger. So we have in Hibernate where I am right now, and for another session I developed an entity framework application. This query fell out of that entity framework application. I should note I am not a developer. I have a C# background, but I don't exercise it very much. So my goal with this was to make sure I wrote 0 SQL queries. I wanted Entity Framework to write everything for me, and it did. So we're going to run this against worldwide importers. We're going to generate a plan. And this will take a minute. While this is running, does anybody have any questions? Yes? Does a CTE work the same way as a correlated subquery? In the outer reply? Yes. Mm-hmm. I want to say yes, maybe in some cases, not necessarily. True. I guess it's similar to a correlated subquery that, yeah, it would return everything, although in the instance that comes to my mind, the situation that I had to write, I moved the cursors with replaced them with correlated subqueries. In that particular case, they were looking for certain top 1 values, and right, and that was the case that I was dealing with then. So. Yeah, true. I could do that, yes. Okay, so this thing is done, and boy, is it ugly. We have over 500,000 rows here. What do our stats look like? So in this case, we have multiple table scans. So our invoices table, our customers table, we're scanning those multiple times. We have a fair amount in the way of logical reads here on this one. Let's see, what else? I have a work table. Quite a bit's going on here. This took over 57,000 milliseconds to run. And our plan, we'll view it here. It's a very large, ugly looking plan. In fact, let's save this off real quick and see how's my plan says. And we'll plug in the statistics to the parser as well. Let's go back and grab those. Okay. So save execution plan as, and we're going to say invoice query. I'm going to get my stats. Come over here. Oh, by the way, I'm going to be putting everything on GitHub. Everybody using GitHub? Yes? No? Maybe? It'll be easy to get to. All right, so let's go to statistics parser and paste our stats in. All right. So this is really cool. it takes all that text data, and puts it into some nice looking graphical tables. These can be used, do a clip on your screen or, print screen, and you can save this off and send this to the non-SQL Server people to help explain what is going on. So, say our invoices table, we're scanning that table 3 times. We have over 34,000 logical reads. We need to tweak our code. We need to make some changes here. We can't, always index everything away. That's, when I hear someone, say, I ask them, how do you address a long-running procedure? And they say, well, I look at indexes. You can't index everything away. Sometimes you have to go fix the code. So this is going to give us a lot of really neat graphical stuff that we can use in making that case. Back over here to how's my plan. Let's go get our plan that we saved off. Where did we put that? Right there. All right. Okay, it's uploaded. All right. So, some big problems right at the top. Let me blow that up a little bit for y'all. We have no where clause in our query. No where clause at all. We have some implicit conversions, desired memory grants that are happening that are not optimal. We spilled a TempDB. There was a TempDB spill, and we wrote to TempDB 8 times. That's not good. We need to try and make this better. So I took this query, and before we look at the better query, let me scroll through this really quick. This query is comprised of multiple subqueries as well as union all statements. So I have my query here. I keep scrolling and scrolling and scrolling. Subquery. Then we union all, another query. Subquery. And it's all wrapped in the whole thing is a subquery wrapped in itself. So I wanted to try and unravel this and make this better. So I turned it into a CTE. So there was one particular query that seemed to be the base query. So I put that into a CTE and then constructed my other queries around it. You'll notice here I'm casting a bunch of values as nulls. This was done in the original. I couldn't get around this, at least not at this time. I may have to go back to the developer and find out what happened here. What can we do here to make this better? Do you need all these columns? So let's run this. Let's make sure we get our stats. Statistics IO on. Time on. And we're going to use worldwide importers, which we're already on. And we want our plan. All right. This will also take a minute to run. But we get a little bit better results. A little bit. I think this should complete in about 30 seconds or so. While this is going, does anybody else have any other questions? Okay.
How long ago was this written against the Entity Framework?
How long ago was this written against with Entity Framework? Very recently.
But not with .NET Core.
No.
Yeah.
No, it was not. This is something I did on my own machine, Visual Studio 2017, just trying to shove some stuff in there and make queries pop out. Literally, that's what I did. Because I'm working under the assumption that the folks that are doing the app development want to write zero SQL, and that's what I wanted to do with this. Write no SQL at all, but get queries. All right, so we have our results here. We're a little bit different from in our statistics. Not much. We have, let's see, the overall time. That's the wrong query. So our original one, how many, it ran over 57,000 milliseconds. This one took 35,000. We're getting there. We're getting better. Our plan, though, is still kind of about the same. We still are scanning our tables multiple times. So what do we do now? Where do we go from here? Well, what about a temp table? Same thing. Turn on my plan, make sure we grab it. So in this case, the initial query, I'm dropping all of that into a temp table called CTE, because that was the easiest thing, and I've changed my names. We're just going to call that temp table CTE. We get the same thing, a little bit different plan. Our stats should be different. It's chugging away here. There you go. All right, so in this case, our stats are better. We're not scanning our tables multiple times. We're scanning them one time. And then we come down here, and now we have one query with the unions, or union all statements, and the only thing we're scanning more is our invoice lines table. So what do we do now? Well, we can try indexing our new table and see what happens with that. See if that helps, see if an index on our temporary table will help get better performance out of the tables that we're joining it to. All right. Last one of this. All right, kick that off. While we're waiting on that, on this one, our elapsed time went down slightly on this one. And the execution plan here, let's look at that. So our first query, it's a smaller plan. It's a breakdown, a smaller subset of the main query that we're looking for. And then our big query that pulls everything together, returns our data set. This is better. This is something easier to look at and manage, and plus our time went down. So is this one should be done. There we go. So we're down right now to 30,000 milliseconds on this query. I feel like we've done a lot on this. We've come quite far. With that index, we reduced the scan of our invoice lines table to 1, logical reads to 5,003, but we're at a place where we don't know what else to do with this. We've done quite a bit. We've got the same data set being returned, but at this point, I'm going to go to the developer and find out more information. We have a lot of columns in this. Are they all necessary? A lot of redundancy. So how can we improve on this? Not only get it out of the dynamically generated query that it is within any framework, but get that into a stored procedure that's handled a lot better by the optimizer. And how can this code be better? Because surely the application is not using everything here. Surely we can cull this down somehow. All right. Let's talk about Query Store. So we have, within Query Store, you have certain things, within SQL Server 2016 and 2017, you can enable Query Store against your database. And we've already done that on our AdventureWorks database, so we should be collecting data. So let's go take a look at some of what we've done here. So you have what are called regressed queries. This is going to return you information on queries that have gone back and maybe used an older plan or regressed. And if that's causing a performance issue, you can get that information from Query Store. Also, overall resource consumption. This is going to tell me, on various queries, how many times something's being executed, or what the duration is. So it's returning some values here. Actually, we're going to turn on my application here and kick that off and let it run and see how that changes our Query Store data. Like I said, this is a very bad Entity Framework application. No queries were written by this app, or no queries were harmed. Well, maybe. Harmful queries were generated. All right. So we'll give this a few minutes and let it sit there. This is going to rerun things every 10 seconds or so. And we'll let that go. Also, within Query Store, it is possible to force plans. So say, let's go look at our queries here, or look at what's being collected under top 25 consumers. Say we want to, find one. I don't know that I have one that has more than one plan. Let's see here. If it's called the same plan multiple times, we should see more dots over here. So it's still going. Let's refresh this. So here's our query from earlier. Let's look at this. So here's our CTE query. Say if we like this and we want to force the plan. Sure, let's force the plan. Okay, so every time that runs, we're going to be using the same execution plan. And we can go over here and review our forced plans. And while our application's running, let's try that one again. Let's see which one were we. So forced plans. Okay. Actually, this is the one. It's the one for our temporary table, our CTE. Yeah, we'll run them both. All right, so we've kicked both those off. Our application's running in the background, generating more data and more queries. It'll also return queries with high variation or differences in what's running. So in the application, the queries that are running there, in some cases, they're only selecting a top number of records. So if we look here, it had one. Here we go. This one's just selecting a top 1,000, and this one's being generated dynamically by Entity Framework. And I don't know if this is the best plan for this query. So if we go back and look at our force plans, and our query should have completed by now. Oh, what happened? We disconnected. I don't know why that got disconnected. Okay. We'll kick it off again. Invalid name. Okay, I'm on the wrong database. There we go. We'll try this again. And our query with our temp table instead. That completed. All right, so if we go back over to our resources, couldn't connect to the database. Okay. All right. I got an out of memory exception. Okay, I think I should kill my application. We'll stop that from running. Ooh. There we go. Okay. Phew. All right. So let's see if I can configure this. It's looking at quite a few days. We want to look at right now. Let's look at the last 2 days. All right. So this is, gives me more information about what's been going on over the last 2 days with what's been running. What kind of queries, are running in my server. And you can derive all kinds of information from this. As you can see, we have the ability to, we're collecting our execution plans here within Query Store. We have the ability to force plans in the event that we need to. Or we have a plan, we have a query that's going rogue and not using the plan that we wanted it to. There are some caveats with Query Store. So say you have a query that has even the slightest difference in it. It could be just one space. If that is not the query that you're forcing a plan for, then the forced plan won't happen. So it has to be exactly the query that you set to force a plan on. So that's one little nuance within Query Store. Any other questions? No? Okay. All right. Well, I think I've covered just about everything that I need to cover here. Like I mentioned, everything is going to be on GitHub. So I'll be posting my slide deck there, as well as all scripts. Does anybody have any more questions about, anything, Query Store? Yes, yes, yes.
So we've done this whole thing where we've gone back and forth between CTE and temp table and CTE and temp table.
Yes.
And, I know there's a lot out there, CTE versus temp table.
Yes.
Is there a good place that you found where there's just some rules, some general guidelines of when a CTE is better or when the temp table is better, so you just get started in the right direction without just rewriting your code or refactoring your code over and over and over?
Once again, it depends. It really depends. My general rule of thumb with temp tables and table variables, if it goes beyond 1,000 rows, usually, that's my threshold for a table variable. If it's over 1,000 rows, I'll err on the side of using a temp table. As far as CTEs, I saw a CT, at one point I was working with some code and there was a CT that was performing poorly for some reason. I changed it to a join in lieu of the CTE, and it worked so much better, and I was wondering why the heck was this done this way. So, I'm sorry? It's happened to you too? Yes. It just really depends, and it depends on what the optimizer thinks is best and how it handles the code. Depends on the size. In this case, it was a very, very small query. It was very small in the CTE. It's tiny, and I was just like, yeah, and it was just not good for small amounts. Well, then that would be why. That would be why it was bad. But yes, it was a very small query and it had a CTE.
So those kinds of examples, but just when, that's the kind of list I'm looking for. In general, if a CTE performs poorly with a small table, and a temp table in general, or a temp variable, that's a good rule. But, some things like that, is there a place where there's just some lists, for new people when they're coming in and code? You want to write good code, especially if you've got a developer from a language. I'm just looking for that list.
Well, there's lots of good blogs out there on the subject, lots of very knowledgeable people. Like I mentioned, the cursors and cursors that I rewrote. That developer wasn't thinking in terms of set-based operations. And, I was. I'd been doing that for a number of years at the time, and I was, I thought more in terms of how can I, get this done in one query instead of, an R-bar operation, row by agonizing row. How can I do this set-based? And that's, I dug into the code and figured it out. But he wasn't of the mindset to do set-based operations, so he did it however, he just did it his way. But I see what you're saying. I normally, if I have a problem, I just search it on the internet. I Google it, and I look at more than one thing. Because
Which is great when you're, when you're debugging and things.
Mhm.
But in general, if you're trying to coach and encourage new developers, people that are new to T-SQL,
right.
it'd be nice, to have a setup. Just these are some things to avoid.
Just tell them don't use no lock.
It's trial and error. Some things work better than other things depending on what you're doing.
Right, but it's that whole idea behind artificial intelligence. If we can make that decision in our brain, there ought to be a case statement that I can write that will help newbies at least be able to look at, to be able to start to make those decisions. Right? I mean, that's what I feel. We should be able to have a case statement that at least gets them in the right direction to do the trial.
we've started developing those kinds of standards where we say, as a general rule, if you're expecting any more than, say, 10 rows, a table variable is probably not a good idea because the estimator is going to say, I'm going to guess that you have one row coming to you. Of course, that's different in 2019, but it depends.
Yeah, it depends. And when I was testing that, I, you know, in the situations that I was working with, I was trying, you know, table variable versus temp table, and I was, you know, looking at both to see what both did for performance, and you know, kind of came to the 1,000 row, you know, 1,000 row rule based on just what I saw where I was at the time. Is that good for everything? Probably not. I mean, it depends on the situation. It depends on the amount of data you're pulling back into that. Depends on, yes, depends on your servers.
There's so many variables.
Yes, there are a lot of variables that go into it.
I usually tell my developers, you know what, try them both. I mean, a table variable versus a temp table, they're not that hard to change.
Right. It's not that hard. Yeah, you're right. It's very easy to change that code. But yeah, I've seen some developers, and this is one of the things that bugs me as a DBA. You give them one thing. There's, or maybe one little one-off situation where I think there was one case they were doing a lock on, you know, a stored procedure. They were calling it, but basically holding it hostage, and it couldn't be run by anything else. And they were doing that in quite a few places, and I'm like, this can't be good. And they thought that was going to solve a lot of their problems, and it didn't. It made things worse. Yes.
In terms of the table variable and temp thing, one of the things that we run into is the temp table functions.
Temp table functions?
You can't use the temp table in tables.
Yes.
So I had a write a certificate of analysis, and we had two tables that were ready to all separate table functions.
Mm-hmm.
Category that takes table function, it all runs in like 2 seconds. But I am returning 40,000 rows into a page variable,
Oh gosh.
and it actually works in 2 seconds. It is very fast, very fast. Now I'm just really surprised about that too, and you were afraid of it.
Yeah.
Anyway, I could go because I had table functions that were writing data out, and I needed a temp area. The only way to do that function is area. And we're also making file frames. I don't know if that changes the way
Yeah. And yeah, you're right. You could do something like that in that particular situation. It's the perfect solution, but in other cases, it might not perform as well.
Another little aspect is temp tables versus table variables relies on SQL internals. Each time it's been handled differently. Each service pack has been handled differently. How much is immediately being spooled into the temp DB versus how much is kind of in that quasi-RAM cache area happening there. Every version has treated it differently with a different threshold. You're better off looking at it in terms of a memory footprint. How big of a memory block are you actually having to work with in a table variable, depending, and looking at that in terms of moving to a temp table. As soon as you go to an actual temp table in temp DB, you're looking at concurrency issues. For that, with any systems, that is a big thing.
Yeah. Yeah, that could definitely prove to be an issue in some places, you know, on some servers. Yeah, I agree. Does anybody else have any questions? Yes.
I need to do a select on a table where there's an absence of records in another table, and I'm doing like a select count equals 0, you know, in a subquery.
Okay.
Is there a better way to do that?
Okay, so you're trying to select against a table with nothing.
Well, I'm looking for no related record.
We're not in.
Kind of, but I just wrote it, you know, like select count of this kind of record in the other table, and if the select count is 0, you know, then it's okay to do the select in the main table.
So,
Where not exists. You where not exists, do your select from the other table in parentheses.
well, I was thinking in terms of left outer join.
How do you know it's null?
Yeah, because if you're doing a left outer join, you can test for where data exists or doesn't exist.
So I would do the left outer join and just say where the other table has nothing or it's null or.
Yes, yeah, yes, yeah. Join on the table with left outer join, and you'd be joining that primary key value and where the values in that table are null.
The other way I've done this also is sometimes you do stuff like and do it an except. You know, you have to be table and your secondary table, and you use the primary key and relationship.
Mm-hmm.
Do an except and whatever's left over, or you do a minus, so whatever's left over says this is what's there or not.
Yes, that's another, using accept is another method of doing that. I will probably err on the side of the left outer join just by default. For if I'm writing it for the first time, I would do a left outer join just to see what happens and see what comes back. And if that, you know, is sufficient and fast enough for what I'm doing, then great. If not, you know, if I'm expecting something else, then I would, you know, keep working on it and query further. But yeah, left outer join, you know, is a, yeah. I guess it's the old school method. Yes, where the value, yeah, left outer join, where value is not null. Yeah.
That's something that I notice sometimes with my younger developers is they'll come across a problem and they'll have like nested selects with where clauses, and I'm like, you're overthinking it. You just gotta take a step back and look at it from a fresh perspective, because a lot of times it's as simple as the left outer join.
Yep. Absolutely. Yeah. I mean, yeah, sometimes it is, yeah, like you're right, it is that simple just to do that type of join to the table and, you know, return, you know, where value is not null. Yeah.
Although any DBA who deals with a highly transactional system, their first reaction is going to be to go over and cut off the head of development who uses
Oh,
You could responsibly use outer joins.
Yeah, but having dealt in e-commerce,
yes.
no way.
Well, and that depends. Yeah, and I agree, because in our system where I am right now, it's highly transactional, and just even the slightest change can throw things into a tizzy. My boss one day applied a trigger in production, and it took things down. And he did it in a vacuum, in a bubble. He didn't tell anybody he was doing it. And yeah, he did it. And without checking with anybody, without doing it in test first, and lo and behold, we stopped taking sales. So, oh gosh. Any other questions? All right, well, thank y'all for coming. I appreciate it.